Hello. So this is my thesis on vertebral fracture prediction. And for those of you who don't know, this is Ellen DeGeneres. And she is sad here because she has osteoporosis, and that's making her daily life quite painful. And this is the case for many individuals. About 30% of all individuals over the age of 50 will develop a vertebral fracture. And vertebral fractures have quite a high mortality rate, as 1 in 3 people with vertebral fracture will die within a year of fracture. And one of the scarier things to note is that 2 in 3 people with vertebral fracture are undiagnosed, as these fractures are notoriously difficult to detect. So that brings me to the aim of this project, which is first to develop a method of identifying vertebral fracture from CT images of the chest and abdomen that were taken for whatever reason, and using that to try to improve that diagnosis rate. And the second aim would be to develop a prediction model to predict who will develop a vertebral fracture, also based on CT images, and with the aims to improve time for intervention and reduce that mortality rate. So to do this, we'll start by developing a machine learning tool to identify vertebrae from CT images, and we'll use this tool to develop another machine learning model that will analyze the vertebrae and differentiate between those that are fractured and those that are healthy. So I have an example at the bottom of the screen here where you can see a healthy vertebra in light blue and a severely fractured, grade 3 fractured vertebra in red. And this model will also output a list of clinical risk factors and bone properties that are most highly associated with the identified fracture. And that brings us to our final model, which will use longitudinal scan data along with the clinical risk factor and bone property data to output a 10-year probability of fracture for Ellen. And we'll also see which interventions may be able to modify that 10-year probability fracture and incorporate that into our model. And together, when these models are incorporated into routine clinical CT scans, we can help to improve that diagnosis rate and reduce serious complications associated with osteoporotic fractures like serious injury or death. And this will also allow for more time for intervention, and that can help to guide treatments like medication, physical rehabilitation, and physical therapy that will help to ensure that Ellen can live a much longer, more comfortable, and happy life. Thanks.
Any questions for Vinny?
Presentation. How early scans will you be taking to be able to predict the fractures?
For the prediction model, yes. We'll be using clinical scan data that's already obtained for individuals who have scans that are at least 10 years apart, so we can analyze the outcome of those individuals for the subsequent 10 years.
Does Ellen actually have osteoporosis in real life?
She does, yeah. She's very vocal about that, so hopefully we can help. Yes?
So I'm curious about this 1 year after death statistic. So is it, why do we think this is? Is this related to complications post, time in the hospital? Is it correlated with age? What?
Yes, so basically it's correlated to complications that come from the vertebral fracture and a more sedentary life, and yeah.
That's interesting. All right. Thank you, Vinny.
Thanks. Good job.